We have a registration table at the front, so please make sure that you did register. It allows us to kind of have an idea of how many people are coming. There's also name tags if you want to have your name tag out. If you do not want to be in a picture, then make sure you get a name tag that is orange, and then we'll know not to post any pictures if we see anything orange. If you want a picture or you're okay, you can wear purple or nothing at all. Will indicate you're okay with a picture. So, yes? Oh, Esther, apparently I'm muted for the Zoom call. Thank you. Can you guys hear me now? Okay, thank you, Martin. Okay, so my name is Carrie Ty, and along with Marta Eschetti and Esther Collier, we represent Climate Action Richmond Hill. It's a merger of Target Climate Change, Drawdown Richmond Hill, and Neighbors for the Planet. In York Region, a network of climate action groups is expanding, with each group dedicated to assisting their respective municipalities in mitigating the expensive consequences of climate change. These efforts involve minimizing local emissions and aiding residents in adapting to the imminent challenges posed by the climate crisis. This is very timely, as you know, as we have leaders gathered in Dubai for COP28 in their yearly effort to stem global warming. Collaborating with the City of Richmond Hill's sustainability section, we've recognized an ongoing challenge in effectively communicating climate targets to residents. This event aims to address that gap by clarifying the municipality's objectives, the reasons behind them, and our role as residents in achieving these goals. It's remarkable to discover that the city's set targets not only contribute to reducing climate impacts, but also yield substantial financial savings for all of us. According to the city's Community Energy and Emissions Plan, and I quote, in 2016, the average Richmond Hill household spent on average $5,400 on energy per year. This amount includes money spent on electricity, natural gas, gasoline, and diesel. By 2050, in the net zero scenario, that figure is reduced to just under 1,700. By 2050, cumulative net benefits reach 12.3 billion and are still growing. A crucial step for everyone is to initiate conversations about these targets with a wider audience. I would now like to recognize the traditional lands on which we are gathered. People indigenous to this land have always recognized the need to protect the land. We acknowledge their presence and knowledge in this land acknowledgement. Since time immemorial, First Nations people have both a physical and spiritual connection to the earth, which is based on respect and gratitude. The nature of this tie is not one of ownership, but one of stewardship. As the earth warms and the waters rise, Indigenous communities are on the front lines of the climate crisis, from James Bay to Nunavut. May we hear their cries for justice. May we feel the groans of the earth. In this moment, let's commit to joining with all creation to work for healing. And now I am delighted to introduce Mayor David West to help us open this event.
Well, thank you, everybody, and certainly great to be here. Actually, I feel like I'm living here, and Majid and Scott Thompson are here as well. We were here last night as well for another thing. We didn't sleep here, though, I promise. It's really great. I've been looking forward to this event for quite some time as the mayor, but also on a personal note, because I actually am thinking about the future of our heating needs at our house as well. So I'm looking forward to hearing lots of different perspectives and conversation and good information about this. I just did want to start by thanking Carrie and the whole group that's here. And it's funny, you mentioned all the different individual climate focused groups that are involved today. This is going back, and I guess, a number of years. We decided that we would declare a climate emergency in Richmond Hill in the last term of council, nothing was really easy, but we did end up passing that. And Carrie, your group, and along with all the others, were very instrumental in doing that. And since that time, it's been a real honor to be able to work with you and all the rest of those groups, because I think this is the climate crisis is something that really is very much being driven by a grassroots type of movement. And we're seeing that here in our community. We're seeing that across the world. We're seeing that more in COP28 now, so far even than I ever recall seeing it. So I think this is really good. I'd also like to acknowledge Scott Thompson, as I mentioned, who's here from our council. Thank you, Scott, for being here. This is actually Scott's ward, so he might actually live in the church. I don't know. Majid Johari, our MP, is here as well. I think he'll be introduced later. But I also want to introduce Miles O'Brien from our staff. We are committed in Richmond Hill to do all the things that we can to protect our environment, to build in resilience into our system. And Miles and his group is really at the forefront of the work. It's really good work that's being done to do that through Resilient Richmond Hill. We have our community energy and emissions plan, which I'm very proud of, that is committing to a net zero greenhouse gas emission community in Richmond Hill. And there's no way we're going to get there without the help of individuals. We can provide leadership, and we will, but individuals need to be a part of that too. And seeing everybody here today really gives me a lot of hope that that's going to happen. So you certainly didn't come to listen to me today. There are people that have way better information than I do. So I'll just say thank you. And again, thank you to all those that organized this. Thank you.
Thank you, Mayor West. Your steadfast support for climate action has consistently been commendable, and we sincerely appreciate it. And as you mentioned, all of the things that we have managed to accomplish at council. I know you've already kind of acknowledged some of our dignitaries, but I also wanted to do that as well. So MP Majid Johari is here. Thank you. So any questions about the funding, you know who to ask. MP Leah Taylor-Roy was going to try to make it, but I don't see her, so she's not here. Regional Councillor Joe DePaula, I thought was going to also try, but I don't see him. And I do see Scott, so from Ward 2, like we said. Scott, thank you for coming as well. And we do have regrets from MPP Michael Parsa, as well as Ward 5 Councillor Karen Silovitz. We want to extend our heartfelt gratitude to our distinguished guests for their invaluable support in promoting this event. Your contribution is truly appreciated. And finally, the moment you've all been waiting for, I would like to introduce our keynote speaker, Eric Jansen. Eric is a research scientist with the Sustainability Technologies Evaluation Program, otherwise known as STEP, of the Toronto and Region Conservation Authority. For the past decade, he has been a scientific lead on data monitoring pilot projects, evaluating the performance of emerging low carbon technologies. This has included a focus on heat pumps, with pilots conducted both in STEP's Archetype Sustainable House Lab and in real world homes and buildings. Welcome, Eric. And I just want to say that unfortunately, Eric will have to leave right after his presentation, but he did say he could spend a little time on questions. So before he goes, so Eric.
Hey, hi everyone. Thank you for coming here today. Eric Jansen. I'm a research scientist with the Toronto Conservation Authority. I was invited here today to present some of the research we've been doing to help make the case for heat pumps. So let's get started. Slide, please. So first, a quick introduction to my organization. I'm from the Sustainable Technologies Evaluation Program. We're a not-for-profit collaborative initiative within the Toronto Conservation Authority. We do research to help support the uptake of different emerging low-carbon technologies for homes and buildings, and heat pumps are one of the technologies we've been interested in. Historically, a typical project for us would be to take an underutilized piece of equipment, put it in our lab, which I'm showing there, which is actually right up the street, measure how well it performs in a sort of pseudo real world environment so that we can de-risk it for homeowners and eventually see that it gets adopted. The first cold climate air source heat pump that we installed was back in 2009. So although the topic might be new for you, we have been operating one nearby for more than 15 years. What we're finding more and more that as the technology gets more advanced, homeowners are putting it in their own home. We can get out of the lab, we can measure the performance in real world homes and share the experience of actual homeowners. And we'll share some of that today. So just a quick introduction to myself as well. I'm a research scientist with STEP. I've been with the team for 10 years. My role is to lead some of the pilot projects that we do, evaluating heat pumps in both buildings, large and small. Before STEP, I worked for a heat pump manufacturer, developing control algorithms and doing testing in a lab environment. My educational background's in physics, like undergraduate and master's. And I say that just to clarify, I'm not a system designer or installer. I'm also not a mechanical engineer. You can think of me more as a data scientist that specializes in the performance evaluation of heat pumps. And I picked up a lot of practical lessons learned along the way that I can share today. I should also qualify, I'm from a not-for-profit, so we don't sell products or services to homeowners. Outline of the talk. Firstly, why are we talking about heat pumps? What's the buzz about? What is it exactly? I want to just quickly share some lessons from my own home because I'm a proud heat pump owner for getting close to a year now. An overview of some of the data collection that we've been doing in the research that we do, and also just quickly some general guidance for you in your home, and I can point you towards some resources at the end of it where you can learn more. So why are we even talking about heat pumps? The most succinct answer is climate change. Now, for most of my life, climate changes seem to be something that was maybe off in the distance, maybe happening to other people. But if you're paying attention to the news, we see the impacts of climate change on Canadians more and more every day. I don't need to give you a laundry list of all the different ways it's impacting people, but we can look at an example. One of the most jarring ones is the heat dome effect that happened in Lytton, BC in 2021. The air temperatures on the ground reached 50 Celsius. More than 600 people died as a result in BC, and I think more than 1,000 in the surrounding region. And the town was eventually consumed largely by wildfires. So some scientific researchers, they looked at the data. This had, of course, never happened before. This was unprecedented. They tried to understand what were the factors that went into it. And it's a complex phenomenon. But at the end of the day, what they found was that without climate change, it ultimately wouldn't have happened. And they're projecting the trajectory we're on right now is that events like that in that area might be possible every 1 in 10 years. So the impacts of climate change are severe. The scientific community says we need to address it, and we need to address it quickly to mitigate some of the worst impacts. The good news is we know the cause of climate change, and it's carbon emissions caused from human activities. And we know where the carbon emissions come from. There's an organization called the Atmospheric Fund. Every 2 years, they do an inventory of where the carbon emissions are coming from in the greater Toronto and Hamilton area. And it's more or less the same story in that our sources of carbon emissions are primarily homes and buildings. They make up about a half. And within homes and buildings, it's ultimately the stuff we burn to heat water and to heat our spaces. So ultimately, so that would be natural gas, or also some people calling fossil gas, oil, and propane. So we're interested in air source heat pumps ultimately because they're a way to efficiently heat our buildings that don't burn things that causes climate change. One of the interesting things or things to note from the recent TAF inventory is that they found that the emissions are the highest they've been through since 2015. So we're actually still traveling in the wrong direction, and we'll have to do a lot of catch up. I also just want to quickly note, again, heat pumps might be new to you, but as is normally the case, there's other jurisdictions, specifically Europe, that's further along the curve than us. This is just a paper I found about the Norwegian experience with heat pumps. It's been ramping up since 2000, so they're another cool climate. For a country of 5 million people, they've installed 125,000 units. So we can look to other cold climate jurisdictions to see what's possible in our own home as well. So that's the 1,000-foot view. We're interested in heat pumps because of climate change. But if we want kind of a more direct reason to be talking about heat pumps, it's that it's a really good deal right now. There are incentives that are available at different levels of government that make it a really compelling business case. There is the HER Plus, which is available through the federal government in partnership with Enbridge, which gives up to $6,500 rebate for equipment. There's up to $40,000 of 0% interest financing available through the Greener Homes Loan Program. There's also other programs that are available to help with heat pumps in homes that are heated with electric resistance heating and oil as well. So when you look at the business case, it just makes financial sense. And we'll get into that a little bit later. So what exactly is an air source heat pump? I think we could get complicated and talk about compressors and evaporators and refrigeration circuits, but we don't need to be that complex. You can think of a heat pump as an air conditioner that goes in reverse and provides heating as well as cooling. It uses the same physical principles, many of the same components. It connects to the home in the same way. It looks the same. It's an air conditioner. It just heats as well as cools. It works by absorbing renewable heat energy from cold outdoor air. A conventional heating appliance will just take a fuel, burn it, release the energy that was in the fuel, and you're never going to get more than 100% efficiency. But the benefit of a heat pump is that because we're moving heat energy from somewhere we don't want it, which is outside, and bringing it indoors, we can surpass that 100% efficiency limit and get equipment that's more than 3 times efficient than traditional equipment. Ultimately, what that means is more heating output for less energy input, lower energy consumption of the home, and in some cases, lower bills as well. You might be familiar with heat pumps. They've been around in Ontario for decades now. But there is a difference between the heat pumps of the 70s, 80s, and 90s and the modern cold climate versions. And I'm trying to illustrate that right there. The conventional heat pumps that have been around for decades had really kind of a key problem, which was that as it got colder outside, the heat pumps lost capacity. At some point, you'd have to revert to a backup heating system, normally a fossil fuel system that would need to take over. And that would often happen in mild conditions. So the heat pump wasn't necessarily a primary heating system for the home. And what we've seen in the past 2 decades is the advent of cold climate systems that solve that problem by being able to maintain their heating capacity as it gets very cold outside. And what that means is that it can be now the primary heating system for your home and the sole heating system for your home in some cases. This is another kind of illustration between conventional and cold climate systems. The blue bars represent how heating energy is distributed according to outdoor air temperature for a typical home. The conventional systems, like I said, at some point, they don't have enough heating capacity. So they're able to handle the home heating load in mild conditions. Maybe that's 50 to 75%. That's what we've seen in our research. But we compare that to the cold climate versions, they can take a home heating load into very cold temperatures, and in some cases do 99% or more of the annual heating load. And of course, this also depends on the heat pump sizing, I should note as well. And I just want to note quickly that, next slide, please. That heat pumps are really, I'm talking about centrally ducted air source heat pumps today for the most part, but you can really think of heat pumps as being a family of technology. It's not a single metal box that can go in your basement or go outside. There's different types of heat pumps that are suitable for different homes, depending on your needs. Okay, so now I just want to quickly talk about my own home. I want to start off with a little bit of a disclaimer. I'm going to be showing some equipment costs, what I paid, and also give an example from my parents' house. This isn't necessarily my guarantee that this is what you're going to pay in your home. Equipment costs could vary for a variety of reasons. And this is just the overall kind of set the stage for the business case. If you want costs for your own home, I encourage you to speak with the contractor. So in my home back in late January, early February, I installed 2 heat pumps in my home. I installed a heat pump water heater to replace my gas water heater. And I also installed a cold climate hybrid system. So a hybrid system is a air source heat pump that's backed up by a natural gas furnace. In my case, I made sure it was a cold climate system. It can handle, we think, me and the contractor, 99% of the heating load, with the furnace being kind of used in the very extreme cold. The reason in my case for the hybrid system was because I'm on a 100 amp panel, which I talked to the utility. I couldn't upgrade it. I wanted to electrify both my hot water and my space heating, but I didn't have enough space on that 100 amp panel to do the backup electric resistance heating, which I would need for a few days a year. There are some solutions to that problem I've learned after the fact. So you can do quite a lot on a 100 amp panel. So if you're interested in that, you can ask in the question period. But since I've installed this, I've consumed no gas, and it's been all heat pump. Just to give you a sense of the business case, I live in a townhome. Again, numbers might be different for you. The system was $13,500 installed pre-tax, qualifies for a $6,500 rebate. Now we're going down to $7,000 pre-tax, and the whole thing was financed at 0% interest. So I'm paying it off over 10 years. The 0% financing, I'm not going to show you the math, but I think you understand that if the government's willing to give you money and you can pay it off over 10 years, it's a much better than having to just have a single cash outlay today. If you do the math for me, it's like it's 30% cheaper on the upfront cost. So it's quite a good deal. So I've operated it for 10 months now. The comfort's good. In my case, it's about comparable to the furnace. The operating costs are low. I can speak to that in the question period if you like. The outdoor unit's quiet. I live in a townhouse. It's not bugging my neighbors. It's not bugging me. Overall, very happy with the system. I can just give another example. This is my parents' home. They just did this. The rebate program changed in April of last year. They're now allowing heat pumps operating with existing furnaces. And if you're in need of an AC replacement, this is an incredibly good deal. So they got a 3-ton system. So they live in a bungalow in the Niagara region. A 3-ton system should be good for pretty much the whole heating load. Upfront cost for them, $8,000, $6,500 rebate, $1,500 pre-tax net cost, still financed at no interest. So if you're in the situation today where you need to replace your AC, I would recommend you do it sooner rather than later, because this is a very good deal. And it's not just about the upfront costs, it's also about the value adds. It's an inverter-driven heat pump. That means it's going to be quieter to operate than their AC. It's going to dehumidify better. It's going to maintain the heating set point and cooling set point of the home better. So there's lots of other, it's going to be more efficient in cooling mode. There's lots of other benefits that come along with that as well. And it's lower cost. Okay, so now I just want to touch on some lessons from our data collection. As I said, we work with homeowners that have installed them to try and understand their experience. Like I said, we've been involved with heat pump research for the past 10 years, but I'm going to talk about some of the stuff we've been up to lately. Trying to do recorded testimonials of homeowners that have installed heat pumps, surveying homeowners that have adopted it to try and gather their experience with it, and also doing actually looking at their utility data before and after they did the heat pump, and in some cases working with our other partners who are installing sub-metering sensors on heat pump systems themselves to better understand how they work. So what I'm going to do now is just show a video, the homeowner can say in their own words the experience with the heat pump, and then I will get to our data analysis to show the financial impacts.
Hi, I'm Mike Layton. I live here in the city of Toronto with my wife Brett and our 2 little girls, Phoebe and Chloe. And over the last couple of years, we've undertaken to do a home energy retrofit to get our house off of natural gas. And one of the major parts of that was installing a heat pump to both heat and cool our home. We installed the heat pump in the summer of 2021, and we've been through, this will be our 2nd winter, and we've not needed a backup to heat our house, and it's cozy inside when it's freezing cold out here. It's minus 10 out here today. It went down to minus 15 overnight, and our house stayed a comfortable 21 the whole time. We wanted to make sure that our home was a positive contributor to not only our family's health and by not burning natural gas in the house, that means for better indoor air quality, but also we wanted to make sure that our home, where we spend most of our time, where we actually produce most of our greenhouse gases, that we were doing our part to create a better world for our little kids. The cost of the installation for the heat pump was about $5,000. And at that point in time, in the wintertime, our combined hydro and electric bill were around $320, $350. Now that was before the increase to the cost of natural gas. And the combined cost of our electricity bill this year, because we have no gas bill, is around $200. So immediately there in the winter, even in the winter time when we're using the most electricity that we will use with the heat pump, we're already saving money on a monthly basis with with respect to our utility bills. If you're hesitant about getting a heat pump or haven't decided yet what you're going to do, there's three things you should think about. One is the comfort of your home will be improved. The second is the health of your home and the air quality in your home will be improved. And third, you'll be leaving a healthier planet for your kids.
Okay, we can probably cut it there. We don't need to see the credits. I guess just a minute to transfer to the slide here. So we've gone forward and done that. We took his utility bills a year before he did this, a year after he did this, and then we looked at what were the utility bill impacts of all the measures that he did. And I should qualify, it wasn't fully clear from the video. He did an air source heat pump water heater. He did a heat pump for his space heating. He also himself did some light air sealing and insulated his basement as well, which was done in the normal course of just kind of finishing the basement. So this is actually a combination of measures, both electrifying the heating and the doing some building envelope retrofits as well. From looking at his bills, our estimated for 1 year of operation, our estimated savings for him was about $800 or a bit more than $800. $300 of that was because he completely disconnected from the natural gas utility. So I said, I have a hybrid system. I still have a furnace. I'm connected to gas. I don't consume any gas, but I still pay $28 to the utility every month in the event that I'm going to need that when it gets extremely cold. He saved that by disconnecting from gas entirely. We tend to show our results like this in a kind of a grid of, well, if the gas rates go here, if the utility rates go here, these are the impacts. Because at the end of the day, it's difficult to project moving forward where the utility rates will go. But in his case, because he's done both the building envelope retrofit and the electrification, it's hard to imagine any scenario of gas and utility rates where he wouldn't be saving a good chunk of money. So I think it's a good case study. Let's move on to another one. This home is actually in Richmond Hill. So this is a bit more of an extensive kind of home energy upgrades. The next homeowner did something that's very simple. So let's roll the next video, please. Yeah, no worries.
My name is Rick Wu. I live in a detached house in Richmond Hill. The house is about 25 years old, built in the late 90s. I moved in a couple years ago, and when I moved in, I upgraded the windows to a double pane low E coating windows, and also I added insulation in the attic. Last spring, I decided to replace the original AC unit, which is over 25 years old, with an air source heat pump, and to work with my existing furnace as a hybrid system. I'm very happy with it. It's performed better than my expectation. It's very warm, cozy, and also it's very quiet. I have much better humidity control during the heating season, and yeah, overall very happy with it. I bought this air source heat pump because the AC unit is original to the house, is like over 25 years old. So when I go for shopping, I want to compare the cost of installing a air source heat pump or just a regular air conditioning. And I found out that the cost is marginally higher than a regular AC. So I took this chance to actually get the heat pump so that it can work with my existing furnace as a hybrid system. The goal obviously is trying to get some savings, especially with the rising natural gas costs, and also lower the emission from my heating. No, I did a lot of research on the heat pump model, and I understand proper sizing is important. So finding the right unit and the right installer is important. I did some of my own analysis using the online tools that is readily available. So I do not have many problems with that. I think installing a heat pump should be a default when a homeowner is trying to replace their old existing AC unit. There are different types of heat pump for every kind of homes or application, and by doing that, you have the benefits of lowering emission, and also trying to lower your cost of heating through the cost of the natural gas. So, again, I would recommend everybody to do this.
Okay. So this was it was a much less extensive retrofit. He had an AC that was old, needed replacement. He replaced it with a heat pump to use with his existing furnaces. Again, we looked at the utility bills a year before, year after. In his case, savings of around $150. So still quite good. And he mentioned that he paid a little bit more for the heat pump. He actually did this before the rebate program changed. So he did it without a rebate. And for him, it was just a little bit more than an AC. Next slide, please. So we've also, just going quickly, we've done surveys of heat pump adopters. Actually, I should say there's more of those videos, more of those case studies on our website if you're interested in hearing from more homeowners. This sample size for our surveys is relatively small. We've 25 people or so, and most of the people have a more kind of environmental bent. But what we're seeing overall is that the early adopter experience is quite positive, so that's promising looking forward. Wrapping it up now, we do have a guidance document on our website, smarterhomeheating.ca. So I'd encourage you to review that, to look at some next steps. I think we could kind of summarize it more or less in 2 points. One is that don't wait until your equipment breaks down to start thinking about it. That might happen during a heat wave, that might happen during a blizzard, and you're less likely to have a well thought out good solution to your home if you just need an emergency replacement. And the other thing is that heat pumps require special considerations that conventional systems don't have. We talk about it in our document, but it also kind of comes down to the installation experience of the contractor and other service people that you're working with to help give you good advice to navigate some of those pitfalls that might be there. Wrapping it up. So what have we learned? We've learned that heat pumps work. We see that in the data. But I think the success of installations is now a lot more to do with, rather than the technology, the installation experience of the contractor. The early adopter experience that we're seeing is very positive. Generous incentives are available right now, so it can make a really compelling business case, even if you're on a budget. The field data that we've been looking at is showing a savings at recent rates. And whether you're of an environmental mindset and you want to do the right thing by the environment, or you're kind of more just want a cost-effective solution for your home, there's some level of heat pump option that's going to be the right fit for you. So I would encourage you to consider it. That's the end of my talk. You can learn more about some of our work at smarterhomeheating.ca, more videos, guidance document, and what have you. You can reach out to me directly. My email is on the screen. You can get it from the event organizers. We also operate a homeowner question and answer portal. So if you just want to have kind of a high-level question about heat pump answered by a disinterested third party, feel free to reach out to us through that. And just want to quickly acknowledge the funding partners. A lot of this work has been funded by the City of Toronto and the Toronto Atmospheric Fund, and also STEP gets base funding from York Region and Peel Region as well. So I think I probably have about 5 minutes or so for questions. You have a great panel coming up that I'm sure can answer all your questions, but if you wanted to ask me something and I can't cover it in the question period, like I said, feel free to reach out. Thank you.
I'll ask you a quick question. So I'm David Cat, the Ontario Sustainable Energy Association. And we're getting questions about what about ground storage? And also the benefit of improving the building envelope before you site.
Yeah.
Because I just heard we're gonna have to double the electricity load in those 2 new stations.
Mm-hmm.
So giving your comment about the 100 amp service, many of our homes are streets that only have 100 amp.
Mhm.
What about that lowering the peak with either using ground source?
Yeah. Yes. So I only talked about. Oh.
Turn these around so you can, you don't have to repeat that one, I don't think, but.
In the interest of time, I'll say because we have ground source and we've had your TCRA present at our events.
Yeah.
Many of them are too expensive, but there's a clean energy tax and it says ground source heat.
Mhm.
That's the federal government's additional money.
Mhm.
And then I just saw from the Clean Air Alliance that going to ground source as opposed to air source will avoid the peak summer that will require a nuclear station. So
Yes, yeah, that's exactly okay. So our research is surrounded air source right now. So ground source or geothermal is another option. It's the best option for home heating and cooling. It's got the highest efficiencies. It produces the lowest demand peaks. So yeah, I mean, if you're a homeowner and you want the best heating and cooling solution for your home, I don't think there's any debate that it's ground source. But as you mentioned, the difficulty for a lot of homeowners is with the upfront cost. Now, in terms of the demand, I think the demand issue is kind of an issue in two parts. One of the things we've done recently, so we were partnering. Enbridge shared some data from a hybrid heating pilot they did with us. They didn't fund us. The Atmospheric Fund funded us to do the work. And we looked at what was the demand impact of putting these hybrid heating systems in homes. And what we found was that they were able to electrify the homes up to 60% without increasing the demand. And the reasoning is that they had old inefficient air conditioners and the new heat pumps were sort of replacing that. So I'm not saying that hybrid heating is the solution. I'm saying that the demand problem is a problem in two parts. You can get maybe to 2/3 with kind of air source heat pumps of electrifying the heating loads before you start to run into these problems. And then once you get beyond that, there's a whole slew of other solutions that are going to need to be deployed to manage the grid. As you say, ground source, thermal storage, battery storage, and the report you were talking.
Improving your existing windows.
Improving your exactly.
Before you size the heat pump. Thank you.
Yes, exactly. And we saw the benefits of the envelope improvements for sure in the first example that we showed, where the homeowner had done some air sealing. Previously, they had done, outside of the area we looked at, they'd done some other window upgrades, and then they insulated their basement, which their energy audit showed was a major source of heat loss in the home. So all of those solutions will ultimately be needed, I think.
And you need an audit before you can get that 6,500.
Yes. I would encourage you. So I couldn't really go into the details of the incentive programs. Go to the program web pages, make sure you understand all the rules and requirements before moving forward.
Okay, so a question. So for your hybrid system, what is the true HP to that
for me, I've set it at -15 for now. We haven't gotten that since I installed it, but we've been right down to that level. I expect it to go colder. The design temperature for Mississauga, I think, is -18. So that means 99% of the time it's above -18. So we're thinking that, yes, I was get back by gas, but it's going to do, I'm going to go from maybe 1,000 cubic meters of cubic gas consumption per year to several, maybe not at all. So it's a solution for me to constrain service panel environment.
Hi, my name is Elizabeth. I live in Richmond Hill for 11 years. And I live in a bungalow with 2 children and my spouse. And I'm coming from the perspective of greenhouse gas reduction emission. I just wonder if there's a framework where the government or TRCA is monitoring this kind of technologies being implemented in homes and buildings and meeting a certain greenhouse gas reduction emission that's in line with the provincial or municipal goals.
So what do you mean by framework exactly?
It's like a way to measure, these houses have implemented these technologies, have reached these goals, and is it calculated over time to see if it is meeting our goal?
Okay, so you want to know if you were to do a retrofit, how do you know if you're kind of actually saving?
Not individually,
Yeah.
but from a research perspective, like, is it meeting the goal, let's say in Richmond Hill, that
Mhm.
they're meeting, net zero, or the government in Ontario? I don't know if there is such a framework looking
Yeah.
at.
Okay. Yeah, our work is a bit more ad hoc. So we try and just tell the stories of homeowners that have adopted it, try and show the success stories as well as the lessons learned. In terms of how well I think the municipalities are tracking the impacts of this, yeah, I'm not sure at the end of the day. Maybe there's someone from Richmond Hill in their period, they could say the extent to which they're tracking the installs and whatnot.
Okay, so do they have any hybrid air and ground heat pump systems?
A heat pump system that used both an air source heat pump and a ground source
No,
heat
it
pump?
doesn't make sense.
Yeah, okay. I'm not sure that would generally be required. It might exist. If you're installing a ground source heat pump, you'd probably not need another heating source for your home. So yeah, I don't think that technology exists
It doesn't
or
make
is really
sense to
needed
exist.
for that matter.
Okay, thank you. I know in Richmond Hill, we've had some issues over the last few years with the noise of air conditioners.
Mhm.
And you've referenced a couple of times in your presentation that this is significantly quieter than an air conditioner. But if everybody adopted this, do you still think there would be a net positive impact on the noise level that we'd be dealing with? Because that would be a fantastic thing from a municipal point of view.
Yeah, I think the noise is important. One of the things that a lot of the heat pumps that are being covered in the grant are driven by inverters, and the inverter driven heat pumps are just quieter and they can operate at kind of lower loads. So your conventional single stage air conditioner that most people in Ontario have bought so far, it's a very kind of abrasive noise. It's not like that with heat pumps, but at the same time, it's a new noise. So that might be an issue. And I think that can largely be mitigated by choosing equipment. And this is where it comes back to installer expertise as well. Where do you put it so that you're not going to annoy your neighbors? And what are the noise decibel requirements of the equipment for certain installations? Like one of the things that we see is that in some cases, if you have two houses that are right close together, you're not going to want to necessarily put a heat pump right here when your neighbor's bedroom window is right there. So I think from a noise level, there's a possibility, certainly in the summertime when people are actually outdoors and enjoying themselves, it's going to be quieter than it was before. And the new noise that you get is going to happen when people are largely indoors behind windows, and it's not going to be as noisy. So I think the noise is an important consideration on different fronts for sure.
Two quick questions. If you were doing a new build, is there a more efficient system if you're using radiant in-floor heating versus forced air? And then is there any truth that these new systems are efficient enough to -30 or -35? I've been reading is that true?
So, I mean, in terms of efficiency, I think it's kind of like is equipment that's available that can maintain some level of heating capacity and function down to -30. Personally, I think that's a little bit moot because we never get that cold in Southern Ontario. It's a nice number to have.
But if you go 100 miles north.
Yeah. Okay. So I don't think, I doubt if you were to look at the specs, the efficiency is very high at -30. What's going to happen is it's still functioning and offering some level of heating output.
Yeah.
In terms of new builds, I mean, there's lots of options. There's also if you want to do hydronic heating, like radiant in-floor, there's air to water heat pumps that are available right now. They're very well suited to radiant in-floor, for example, because that requires more mild temperatures. It can be a bit more you need special radiators if you want to integrate an air source heat pump with a hydronic heating system that uses like conventional cast iron radiators. But yeah, I mean, in the new build environment, you really do have a lot of.
And is this all one heat exchanger that's doing the air source and the gas, or do you have to have a second gas heat exchanger on the other side of it?
In the case of a hybrid system, it's a furnace and an air source heat pump.
Okay.
So it's two pieces of equipment.
Yep.
So
it's two heat exchangers that you need to have, right?
Yeah, it's the same kind of setup as a furnace and AC. There's an A coil in the supply plenum. Same setup.
Okay.
Yeah, I think we're done the question period.
I've
Like
got
I
another
said,
one
you have a
from
lengthy question period with some great experts as well. If you wanted to reach out for me directly, feel free to get my contact info and we can keep the conversation going. Thank you, everyone.
Thank you, Eric. That was really full of great information, especially understanding all the options that we have with air source heat pumps, as well as understanding there are cold climate air source heat pumps as well. So there's a lot of information out there, and I know the cold is what scares most people. So that was great. And thank you for your time and your expertise in sharing that with us and allowing us to reach out to you with questions. So thank you again. So it's now time for our panelists to come forward. And they can sit behind the table. I'm going to introduce each panelist who will then give a short explanation of their connection to heat pump retrofits and the expertise they have to offer. Then we will open the floor to questions. So if I can get maybe everybody come and sit down first. And we'll go ahead and introduce. Sorry, it is a bit.
Sorry, guys, 1 second. You can talk with this mic. Sorry, guys. It's ready for you if you wanted to. Okay.
We have to use it so that the Zoom people can.
Okay, so everybody's here. Okay, so Miles, the first name is Miles. Everybody's saying whatever. Miles is the Environmental Education and Engagement Coordinator for the City of Richmond Hill. He develops materials and resources to support the city's sustainability and climate change initiatives and works with community groups, schools, and organizations to promote environmental awareness and action. Miles has played central roles in developing Richmond Hill's environmental strategy, community energy and emissions plan, and internal quality and environmental management systems. So Miles, if you want to go ahead. I think.
Okay, I'm staying here.
Yeah.
Using the mic. Okay. This one. Oh yeah, very nice. Okay, thanks. So, thanks everyone for being here. And I definitely want to thank the organizers for putting this all together. I think it's fantastic and very timely. So I'm really glad and privileged to be part of the event. I've had a couple introductions, so I won't say more about who I am. I'm from the city, work with our sustainability section, and we've worked with the event organizers on a few things over the years. So I think my main purpose here is to make a connection between the topic of the event, heat pumps, and the city's kind of broader goals and targets around climate change. So let me start with our broader plans and goals related to climate change. So you've heard, I think a couple people mentioned so far that the city has something called a community energy and emissions plan. So, and our short form for that is the CEEP. So I'll refer to it as the CEEP. So that really is the city's #1 climate change plan and policy. And what I think is a really positive thing that's been happening over the last number of years is that some of the kind of concepts and considerations from a plan like that are really flowing out into other parts of the organization and other plans and policies like our official plan, strategic plan, energy plan, transportation master plan, all those things. So I think that's a really good step and something that needs to happen. So very high level, I think, you know, what we're calling a climate lens is being applied through these different plans and different departments and filtering into other work. But when it comes to the CEEP itself, so the Community Energy and Emissions Plan, and I think it was mentioned previously, the basic target within that is net zero. So net zero by 2050. And that's really in line with a lot of other jurisdictions across Canada and beyond. I think it's important though, when we say net zero emissions, to understand that itself is part of, a broader vision of what Richmond Hill can be at that time around 2050. So it's not just about, getting down to net zero. It's really about being more resilient as a community. And as was mentioned with our keynote speaker, that can actually have economic benefits. So we can actually have a stronger economy by going in that direction as well. That's part of the vision of the SEEP. And as Mayor West, I think you alluded to in your introduction, it's really something that requires all of us to participate in. So city, businesses, residents. So it really is a collaborative effort. So the SEEP has the vision though, and the target of net zero. How do we get there? So our previous speaker also showed a slide that indicated the major sources of emissions in the GTA, including Richmond Hill, are transportation and buildings. So obviously heat pumps are related to the buildings part. So I think it was mentioned that, or if it wasn't, I'll mention it again. In Ontario, relatively speaking, our electricity production is fairly clean. So when it comes to buildings, it's really our natural gas consumption that's driving those emissions. So again, trying to make that connection between the city goals and heat pumps. Within kind of the building sector, we know that using natural gas mainly for heating water, heating air, that's where our emissions are coming from. We know that we have both new buildings, which was talked about briefly, and existing buildings. And so the SEEP contains goals for both of those. And I can just quickly mention that for new buildings, the city has a program called a Sustainability Metrics Program, kind of like a green development or green design standards, which encourages, in this case, electrification in new builds. For existing buildings, it's really retrofits that are the key concept. And the SEEP, again, really emphasizes the need to invest in our homes and buildings now to get those benefits down the line. And really, it's about electrification, but I think it's important to also frame that, to understand that reducing emissions, it's sort of a multi-dimensional thing. Well, 3 dimensions that I would point to. The first one being reduction. So it's kind of similar with when we're talking about waste management, the 3 R's, right? And people say, well, reduce is the first one. It's the same idea here. If we want to, to really have the greatest impact, the first thing is to look at is how can we reduce the amount of energy we actually need. Then we can talk about energy efficiency. So doing the same thing that we would do anyway, but doing it more efficiently. So using less energy to do that. And then the third thing would be switching energy sources. So for example, if you have a gas stove, you switch to an electric one, right away you're not using natural gas. So to bring it back to heat pumps are a great fit in terms of the SEEP vision and the SEEP goals. They hit on 2 of those dimensions. So they're switching, for a lot of people, they'd be switching from a natural gas furnace or to electric. They're also more efficient, as Eric, the keynote speaker, pointed out. So within the SEEP, there's a couple of specific recommendations around how we can get more heat pumps out there. So one is a bulk retrofit program. So that would be looking more at the economies of scale, right? So instead of doing 1 by 1 in kind of a block of homes or buildings, do that in bulk. And that one's focused more on social and low income housing. The other one is a PACE type financing program. So PACE is property assessed clean energy. And that's where a loan would be provided that is tied not to the property owner, but to the property itself. So kind of making it more property based. And that's been tried, I believe, a lot more in the United States. So currently, Richmond Hill is just starting a feasibility study with the city of Markham to explore that type of program. So I'll just close by saying, currently for the municipality of Richmond Hill, we have that in our plan, in our SEEP. We're moving in that direction. The role that we want to play, because I don't think we have it in our budget to buy everyone a new heat pump, unfortunately. So currently, I think the role that we can really play, especially my section, is facilitation. So how can we make it easier for our residents to learn about and take part in this sort of transition to heat pumps? So just quickly, I'll mention, we've been running a webinar series this fall, mainly focused on sealing your home, so making your home more airtight, but also another webinar focused on general retrofit ideas. So there are 2 more sessions this December in a couple of weeks. We're also running a survey, and if you see my table over there, you'll see a QR code on the poster. That's a direct link to the survey. That's a way for residents to tell us some of your thoughts, concerns, preferences around home energy. And that's really going to be important for us to help develop programs that really serve our community best. So I'd encourage you, if you haven't heard about that or done it yet, to check out the survey. I'll close it there, but really looking forward to our discussion, and thank you again for the attendees and to the organizers. And Carrie, who should I pass the microphone to?
Thank you, Miles. Thank you, Miles, for sharing what the city is doing. And I do encourage everyone to go and have a look at the table that Miles has put a lot of resources together to help, as well as we will have a link to some of those resources on our website. Our second panelist is Marta Esqueri. Marta is a member of Climate Action Richmond Hill and a homeowner in Richmond Hill for the past 40 years. Marta has recently replaced her gas furnace with a heat pump to reduce her green gas emissions and energy costs. And when I say recently, I mean within the last 2 weeks, so very recent. She will share with you her personal experience during the process. So Marta, I'll pass it on to you.
Some of you, we did send out, as our reminder, we sent out a link to our website with the different materials that I'm going to cover today. If you didn't, they were also available there at the registration table. If you didn't get it, it might be helpful for you to follow along. So what I decided to do, first of all, being an environmentalist and looking at some of the goals of written within SEEP, as Miles reported, the city is looking at retrofitting houses to heat pumps by 2050. So we, Climate Action, Esther, Carrie, and I said, what can we do? What's the biggest thing that we can do? And I said, well, I'm going to heat pump. So knowing that my furnace was dying last winter and was inevitably dying this winter, and the funny anecdote is that it actually failed 10 days before I had my heat pump. So do not wait until your furnace fails. Luckily, my wonderful installer came in and rebooted it. So I was okay until the heat pump was installed. So I decided to go with a heat pump for environmental reasons mainly, but also for economical reasons. To me, the fact that I had to replace my gas furnace anyway, and that was going to cost me between $12,000 to $16,000. Then when I started looking into what a heat pump was going to cost, and you take my heat pump and water heater was $21,000. Take away that amount of money and you bring it down to a reasonable level, get the rebate, and you're almost at zero cost. And also the wonderful interest-free loan from the government. So I started to do a lot of research, and you can see by this big folder of mine, and fortunately even though I'm an environmentalist, I'm also a bit of a tactile person, and I like to see things in print. And I have to say, and I'm sorry, Mashid, but the government website is complicated. And that's why I decided for all of you to benefit by my research. And I created this step-by-step guide on how you go about deciding to get a heat pump, but also what you do once you've decided to get a heat pump. So I'm not going to go through each step. I'll go through a few of them. The key one is, first of all, you want to decide or find out if you're going to get the rebate. So you go into the Canada Greener Homes loan. Because you're in Ontario, it'll refer you to Enbridge, the home efficiency rebate program that Enbridge monitors. So, and then that will give you a list of energy advisors. So as someone mentioned earlier, in order to get the rebate, you must do an energy audit. And so the next step is finding an energy auditor. And Enbridge website will give you a list of energy auditors, or you can research on your own, or you can ask your neighbor who's done it. That's the next step. And your energy auditor, and you'll be hearing from Sarah about energy audits, will walk you through what needs to be done and what things you can do to improve your home's energy usage. And also it will help you with facilitating the Enbridge rebate. So those are key things to begin with. And then of course, the next step is you've decided that you want to go with a heat pump. You've got to research getting a contractor. And again, in my handouts, I've given you some suggestions on how to go about finding a contractor. Then the next step for me, because I wanted the loan, I don't have $21,000 just kind of hanging around. I don't know if anyone else does. So I said, okay, I'm going for the 0 interest-free loan that the federal government is providing. And I went through that process, and you can't, that's the other thing, I did not know, and luckily I had not started the work, but you cannot start the work before your loan is approved. So once your loan is approved, and that didn't take too long, then you can decide to, actually, sorry, I missed the step. I missed the contractor step, because you need to get the loan, you need a quote from your contractor. So the next step after the audit was to find a contractor. And again, in my notes, there's different ways to find a really good contractor. And then once you have the quote, the one that you've decided that you want to go with, then you can, go ahead with the loan. Now, I also have provided a couple of other things. So you need, there's one thing that they suggest that you get is just have your your contractor, just sign this form. It just tells you that they are a certified contractor. Another thing I developed, because I had 6 contractors come in. You don't need 6. I did it because, again, I was researching for this seminar, and you need 2 to 3 because you want to compare all the different things. So I thought, okay, as I had them in, what was I asking them? What were they telling me? And I thought, okay, I want to put something together so it's consistent. So I created this contractor quote form. These are the questions you should ask your contractor. And then once you've had all your contractors come in, and as I say, I had 6 come in, I did a contractor analysis, being the engineer in me, I did this analysis in order to narrow down based on all these criteria. So at that point, I made a decision to go with the contractor that I did. So those are the parts of the handouts. I hope you'll find them helpful. I did put my email address on the document, so if you have questions, I'd be happy to answer them. So off I went, and after I got the loan approved, I called my contractor and said, okay, when can we do the installation? And we set up a date for the installation. As I say, 10 days before the installation, my furnace decided to go kaput. And luckily, my installer, Bob, came in and fixed it. Yay. So we weren't without heat for 10 days. The installation went extremely smoothly. We are now happily sitting in a home that is quiet. You don't have, how you sit by in my family room is where the furnace was nearby. And it would roar when it needed to heat up. And then it would die down. When it roared, you have to put the TV up. And the same thing in the summer with the air conditioner. You'd be sitting out, have a barbecue with your friends and roar the air conditioner. Now, I have gone outside to hear my unit. It is so quiet outside, and I'm hoping in the summer it'll be as quiet. But indoors, you don't hear that roaring. it's like a white noise. And the house is heated at the set temperature that we have. It's comfortable, and I am so happy that I made this decision to go with a fully heat pump system. So that's my story. If you have any questions, I'd be happy to answer them. Or as I say, if you wish to email me with questions you think about later, I'd be happy to answer those as well.
Thank you, Marta. Thank you so much for putting resources together for people to simplify the process, because it sounds quite complicated, and making sure that you do things in the right order, or maybe not ending up with the funding you thought you were going to get. So very important. Our next panelist is Sarah Grant, and I just want to make a note that she will have to leave at 3:30. So when we get to the question period, let's focus on any questions going to her first, which is coming quickly. So Sarah is the president and co-founder of Goldfinch Energy. She holds degrees in engineering and computer science and has leadership experience in renewable energy and local food systems. Sarah is a multi-unit residential buildings certified energy advisor and is working on her net zero certification and becoming a heating, ventilation, air conditioning designer. Sarah, turn it over to you.
So the main takeaway from who I am is that I'm an energy advisor. So as far as how I fit into the process and why I'm up here today is to access the rates that Eric mentioned and the zero interest loan. And as Marta said, the first step is if you're interested in a heat pump, if you think it's a good fit for your home, is to get an energy audit. So I actually didn't set out intending to become an energy advisor, but Goldfinch Energy was started just about almost 4 years ago now. And with the idea that I wanted to help people get their homes off of gas. And, you know, I've worked in the environmental sector for a number of years, and looking around just saw that one of the biggest nuts to crack was the residential single family homes. And then when I dove further into what was happening, stumbled upon becoming an energy advisor, and I'm so glad I did. It's such a great fit for sort of me anyway, and I'm always trying to find more folks out there who are why I'm sharing this, because we need more energy advisors out there who are climate motivated, who love going into people's homes, meeting people, have a bit of a technical mindset, and that is exactly if that's you, then being an energy advisor is a great fit. And particularly with Goldfinch Energy, what we will do is our focus is helping people find ways to practically get their homes as far off of fossil fuels as possible, reduce their energy consumption, and sometimes those two go hand in hand. And often we also try and help find ways to make the homes more comfortable. I live in Toronto in East York, so my house is 100 years old, and I have 3 fantastic teammates on the team. We're growing. So Audrey in the gold for Goldfinch over there lives in Vaughan. And so we're growing our team, and but just all that to say, I guess that my frame of reference is most often working in 100-year-old homes where like Mike Layton's, he was actually one of our first clients, actually. You know, his house is still got a lot of room to improve with the building envelope, frankly. But so what we'll do when we go in is we'll take a look at what's possible here. You know, Mike was talking about a basement reno because with the 2 kids growing, they wanted more livable space. And so, okay, great, that makes sense. Let's work on that. Let's replace your aging equipment. Let's make a plan for that. Let's see what else can be done. Maybe some spot air sealing, look at the attic insulation, things like that. So maybe just backing up a little bit. So that's sort of Goldfinch Energy. We're energy advisors. We have a focus on helping people specifically get their homes off of fossil fuels. I'll just say honestly, not all energy advisors do. They may come in more just wanting to help you get the rebates, which is also really important. But if you are looking for an energy advisor, just make sure you do your research, just as you would for a contractor, to make sure you're happy with what you get. So as far as what an energy audit entails, it's typically about a two-ish hour to three-ish hour process where we come in and we're basically thoroughly measuring every aspect of your house, from your windows, looking at your windows, how well performing are they, levels of insulation in your walls, the basement, your attic, if you have one, we'll poke our head in. We'll check out your mechanicals as well. And then the most interesting part is at the end, we'll hook up a big fan to your front door and sort of suck all the air out through the fan and see how much air comes back in, which is a measure of how leaky or not, or drafty or not your house is. And so all those pieces of information that we measure when we're in your home, as well as the photo documentation, which is a necessary part of the rebates anyway. All of that we put into a software program that can tell us your, like, sort of where's your home losing heat, how energy efficient or not is it, and we can do some modeling to sort of say, what if you were to switch to a heat pump? What does that look like energy wise? What if you were to top up your attic insulation? Where are the opportunities that are most practical and feasible within your budget, within your goals? And certainly if you're looking to install a heat pump, I know Eric mentioned this, and I cannot stress it enough, like, make sure that if you have an energy advisor who does their due diligence and takes time to accurately measure everything, they should be able to tell you your home's heat loss. So this is kind of the worst case condition. Eric mentioned in Mississauga, it's minus 18 degrees. I don't actually know Richmond Hill what the worst case can, but sort of the design condition, I know for Toronto is minus 20. So it's sort of the worst case, what's the heating capacity required in your house? And there's no need to install a heating system that's larger than that. And in fact, I know with Marta, we had a lot of back and forth, because there were some contractors, I think, that thought that they needed to install something larger, or needed to install electric backup, which was going to cause her to have to upgrade to 200 amps, which increases the costs. Eric also, the fellow who presented earlier, also found that. So that's not always the case. And it is, having to spend $5,000 more or maybe more to upgrade to 200 amps, that might turn people off of the technology. So it's really, to me, really important to find ways to affordably make this possible for as many people as possible, as quickly as possible, given the climate emergency. The energy audit, we sort of take all those measurements. We can calculate your home's heat loss. There are reports that are generated, and that's sort of the first step to qualifying for the rebates themselves. And as Marta said, sort of, I'm scheduled to come to your house.
Oh, I didn't mention the second audit.
Yeah, so just to kind of close
until you've done the second audit.
Right. So just to kind of close the loop, thank you. That's what I want to say is the process. So you get the energy audit, you'll get your quotes, apply for the loan if you're interested, do the work, whether that's installing a heat pump or more or less, whatever is meaningful within your house. And then you need a second energy audit that's called a post retrofit audit, which is more about proving that you did the work, and will update the information on your house to show, okay, now here's the house where it stands now. And that second audit is used to claim your rebate and close out your loan application. And there was someone earlier who asked about sort of a framework and how all the data is being tracked as far as, are we meeting our targets? And I know one of the reasons that, federally, a lot of the rebates, the heat pump rebate and others are coming from federal funds. And by going through this energy audit process, the federal government then has this data, Natural Resources Canada has this data where they can look and see, okay, how effective are our incentive programs? What are the results on the ground? What's actually happening? They could actually look, geographically as well. I don't know to the extent I'm on the ground, but anyway, I see you standing up. I should move on. I just want to say a few more things, like, right sizing heat pumps. That is so important. So make sure that you work with someone, whether an energy advisor, like an HVAC contractor, both, who can do that. And thanks for inviting me here. It's such a pleasure. It's great to hear all the amazing stuff happening here.
Thank you so much, Sarah. It was great to understand what an energy audit does, or what they should be doing, an energy auditor, and also for the steps of what happens, as well as the before and after audits, and that the federal government is actually tracking it. And so our final panelist is Bob McGarren, and Bob is a principal at Canco Climate Care. He brings over 55 years of industry expertise to the forefront. He's licensed in gas as a master electrician and refrigeration. He is a controls specialist. Canco, which was established in 1984, is a leading heating, ventilation, air conditioning, and refrigeration company focusing on residential markets in York Region and South Simcoe. Bob and Canco boast extensive involvement in the HVAC industry. Bob has served on both Climate Care's board of directors and that of the Heating, Refrigeration, and Air Conditioning Institute of Canada's, contributing significantly to each. Canco Climate Care, recognized for over 35 years of successful heat pump installation, aligns with today's technologies to combat climate change. And Bob, I turn.
Thank you. Hopefully everyone can hear me. Put your hand up if you cannot. Okay, because I have a little raspy voice today, so bear with me. I'm going to skip a few things because they have been covered, but our focus today is about the adoption of cold climate heat pumps, how this technology can be used in the residential sector to reduce your carbon footprint and energy costs, along with increased comfort levels throughout your home. I think that's something we sometimes lose sight of. Yes, we want to reduce the carbon footprint, but we want to make sure that when we are done, you're more comfortable in your home than you were prior to the installation. And that takes a lot of work and some exploratory consultations to get there. The first task is to have the home analyzed with a Greener Homes authorized contractor, or I guess supplier. Useful information is contained in the audit, help you make smart decisions about the next steps in reducing your carbon footprint, making your home more energy efficient and healthier. Another area we haven't talked much about is the health of your indoor air. These calculations are useful to the contractor, along with lists of design requirements to make the installation of your new cold climate heat pump successful. Do your homework. Not all contractors in the HVAC industry know what to look for in the design of your system. I've put together a few items that I think might be of interest to you, something one should look for if I have invited a contractor into your home, and I'll briefly list through them. I know you all want to anxiously get to questions, so I'll be brief. So contractors, does the contractor have many years of experience in heat pump installs and application? Contrary to some thought, many contractors have been installing furnaces, gas furnaces, and air conditioners for a number of years, and not heat pumps, especially Richmond Hill, Thornhill South. It's almost been all air conditioners. The heat pump business, which I've been in for a long time, and I'm in Newmarket, is typically north. And a lot of that is because gas was not available, maybe propane was being used, etc. So our focus has been quite different than what happened down here. Even though we are natural gas contractors, we're also electrical contractors also. Has a contractor spent significant time asking questions about your comfort levels, energy and environmental health concerns? These are questions that need to be asked. Has a heat loss, heat gain calculation been completed for the correct sizing of the equipment? Has a static pressure test been conducted measuring the capacity of the existing sheet metal system? It has been found that when equipment has been oversized and that is oversized is installed, this increases the airflow beyond the recommended static pressure of the duct system, which increases noise levels. Marta reflected that her system is quiet, is because that's taken into consideration in the design. So increases noise levels and can significantly have higher energy costs and reduce comfort. So getting it right on the design side is critical. So that needs to be done. Does the contractor have the necessary tools to install cold climate heat pumps? You might think all contractors have similar installation processes. I'm going to tell you right now, not so. It requires more attention in the installation processes and extensive training to accomplish this installation. Remember that most contractors have been installing ACs and furnaces. Often shortcuts were used because those systems, their ACs, operate in warm climate. When you have systems operating in colder climates, like cold climate heat pumps that can operate down to minus 15, 20, 25, even 30, a whole set of requirements has got to be met to make sure those systems are being installed to some precise standards required for cold climate heat pumps. We're concerned about contamination in the installation of the systems. That could be as simple as refrigeration pipe ending up at your site without being capped. So that refrigeration pipe has moisture in it now and could have contaminants. Having the right tools to evacuate all of that moisture and air out of the system, and having the right processes when either welding or mechanically fitting that pipe together. These are all systems that weren't followed a lot in air conditioning because it didn't show up. That's why. Cold climate, it's going to show up. Commissioning the systems must be completed after the installation to verify performance. Why would one change something without measuring it after to make sure that it in fact does what we intended it to do? And that's an extremely important step. The performance can be the electrical controls, including thermostat and setup. Ensure the equipment details are in writing along with miscellaneous materials and warranties when you're getting a quote. Get it detailed, very detailed. Quotes we give are 6, 7 pages long for maybe 3 pieces of equipment. So we're detailing every item and we cost every item. It's not just a number at the bottom of the page. You want to know where you're spending your money. Ensure that all equipment must be listed on the Greener Homes website to qualify for the rebate. That's really important. Sometimes contractors, everyone's human. We can sometimes, out of inventory, put the wrong coil in. We don't have a number that's matching the Greener Homes, so that's not going to qualify. So contractor's going to have to come back and fix that. It's nice to know prior to having that happen by doing the audit, the contractor audit at the end, commissioning the equipment, etc. Installations can take up to 3 days, depending on the complexity. A lot of them are 1 day, some are 2 days, and the occasional one will slide into a 3rd day. Sometimes that's just cleanup or adjustments or commissioning. That could be the end of the commissioning aspect. Outdoor heat pump must be installed above the highest anticipated snow level. It can't go on the ground like an air conditioner. You may have seen some of those pictures when you were looking at it. They've got to be up off the ground because in the winter time, when they're operating, they have a defrost mode, just like your refrigerator does. And the defrost mode is going to melt the ice on the outdoor coil that will collect, and it's going to drop down to the bottom. and run out the bottom of the unit. We need lots of height there to accomplish that. Can your contractor be reached 24 hours a day? If you're thinking of using a contractor, before you sign the contract, give them a call at 1 a.m. See who answers the phone. I'm serious. I'm serious. Give them a call. Find out what reception you get. If you don't get a person on the other end of that phone, you might want to drop down to the next one on the list. Okay. Does your contractor have qualified personnel capable of installing cold climate heat pumps? You can go on to, I'm trying to think of it, skills, Ontario skill, what do they call it? They call it the Ontario, Skilled Trades Ontario website, sorry. And you can enter my name on that public website. When you enter my name, and best by the way to check licenses by asking them for their driver's license, because who knows if they're using someone else's license. It's nice to know who's in your home. Check their driver's license, put the name in the computer. If they don't come up as a qualified technician, send them out. Don't let them in, because they need to have a 313A or D, which is a refrigeration or air conditioning license. And in some cases, if they're combining it with the hybrid systems, that system is placed on a gas furnace. They need to be a gas technician. Also, gas technician licenses can be checked with TSSA. They are the regulatory agency for Ontario. That's in a nutshell what I think one should be looking for. There's more, but as I mentioned, I want to keep it as brief as I can. And again, thank you for the opportunity of being able to share some of the things that are going on out there. Thanks.
Thank you, Bob. That was an incredible good tips and things to look for in a contractor. And yeah, we really learned a lot from that. I never realized that if you get an oversized machine that it could add noise to your house, which is really important because I think a lot of contractors might, you know, do an overkill to make sure you're comfortable. So some really good points. So thank you to all the panelists for your introductions and things. Now it is almost 3:30. So we have about, just a few minutes with Sarah, and then altogether around maybe 25 minutes for our Q&A. So there are 2 microphones, as everybody has seen, on the floor. To our Zoom audience, put your questions in the chat as you've been doing. I think we've got, Esther, how many people do we have on the chat? Is it about even? 30? So maybe we're about even. So we'll try to grab one from the floor and then go to Zoom for questions and alternate. And I'll let the panelists choose who's going to answer the question unless the person asking the question, it wants to direct it to a certain person. So Scott, did you want to start?
Something that is kind of resonated with me because my wife and I, and my wife's here at the back, we have a 100-year-old home here in Richmond Hill. So I'm assuming that you've done the analysis on your own home, and I hate to think what all the analysis might be on our own. Have you found that there was anything that came up in your analysis that would not be, say, covered through any of the programs, even the interest-free loan, that type of thing?
Items that you could do to improve your home's performance. Okay. Yes. Yeah.
You're going to find all kinds of things.
Yeah. I mean, what I, and I think the data is starting to show this too, is that, you know, sort of when it comes to the rebates and the costs associated with work, if you're starting from 100-year-old home, that's, you know, 100 years ago, there was no building code. So it was leaky as heck and single pane windows and uninsulated. Over time, some people may have improved things to varying degrees. What I think is needed, and I know, David, you actually kind of asked this too, is we do need, the incentives are, in my opinion, not sufficient to help encourage more deep energy retrofits. So when I say deep energy, we're talking about the kind of work that someone could do on a 100-year-old home that would dramatically reduce its energy consumption. So switching to a heat pump might reduce your energy consumption by about 30% or 40%, depending. But I'm talking about work like significantly reducing air leakage, but adding a lot of insulation, not just to the attic or the basement, but to the above grade walls, which is those are costly endeavors. Adding spot air sealing, walking around with a caulking gun is so good if that's all that's within the budget, but significantly reducing air leakage, adding insulation, even just to bring it up to code on the main second floor, however many above grade floors, those items do cost a lot. And so the rebates are not, there are some rebates there, but the proportion of how much they cover compared to the cost is not enough. So this is an area where I think more people are looking at, because as we switch to heat pumps, if you're in a 1980s build like Marta is, your home already has some insulation. So maybe a deep energy retrofit doesn't necessarily make sense, but for 100-year-old homes, we need more. We need the cost to go down and hopefully more incentives as well. I hope I answered your question. Yeah, I can we can talk about this later though, like my own home and what we've done, what we haven't done.
Great. Thank you, Sarah. Sarah, are you still okay for any other questions? Okay. Is there something on the chat for Sarah?
Yeah. There are some questions on the chat. I'm just quickly looking to see if there's any directed to her specifically. Okay. If you replace an AC with a heat pump while keeping the gas furnace, will the heat pump also provide heat to the house in cold weather?
Could you repeat that question?
Okay, if you replace an AC with a heat pump while keeping the gas furnace, will the heat pump also provide heat to the house in cold weather?
In cold weather? Yes.
Furnace will work what?
The furnace works in conjunction with the heat pump. Typically, the heat pump is your first stage heating. When the heat pump can no longer keep up with the heat loss of the home, the gas furnace would contribute at that point. Typically, if it's a cold climate heat pump, we don't necessarily limit the temperature at which the heat pump will operate at in this area. And therefore, the gas furnace would only contribute when you get below the balance point or the threshold of the heat pump's capacity to heat the home.
So does anybody have a question for Sarah before we move on?
I'll ask a fast question. When you're doing the H2000, the audit, so I'm renting, my landlady said, oh, if you can get money from Enbridge, so renters qualify, we have to make that clear. You're shaking your head, so we'll have to ask why not. But let me ask you a question about the building envelope, because clearly whether it's noise, if you improve the existing windows, and I presented this to the Green On Fund, that should be modeled. And it seems that all that the auditors are saying is buy new windows, but it's a 25-year payback. So what is the position on insulation more than caulking?
I mean, yeah. Like lots of advisors will go in and recommend you do your attic insulation, you do spot air sealing, you do windows, because I think what they found is those are the least disruptive items for people. And frankly, honestly, lots of people will chuck really nice windows in the garbage that are not that old because there's a good rebate for new ones. And maybe they decide they want something that's a slightly different size. And then they'll say to me, well, why does my audit not show significant energy gains? And I say, well, look, we talked about this at the beginning. So I think, I think if I'm understanding your question, like, I think what is an energy advisor stance, I think is hard. I can't speak for all energy advisors, but I know myself and our team, we are so committed to helping people when it's financially possible to significantly reduce their energy consumption. So if a deep energy retrofit, if getting your house to net zero, where, you know, first you do the building envelope work, get off of fossil fuels, install solar panels, if that's in the budget, all that is possible for some people. So we will help them work out a plan to make that possible. Insulation is really important. And so, yes, when it's affordable, then it's great. But I think, you know, frankly, like, just like, you know, not everyone is unfortunately climate motivated. So if you're facing a broken air conditioner, heat, or a furnace, more and more people are now thinking of a heat pump because of these rebates. The same could be said of someone, if you're doing a renovation, maybe because you want to change the layout of your house, or you don't like the look of your kitchen, for whatever reason, there's an opportunity there to add insulation, to add an air barrier, to make your house more airtight, do it properly. So these are, you know, going to last for decades kind of work. Then it should be done. But absolutely, it would be amazing if we could all do what we can. Sounds good, David.
Okay, thank you. So I guess we're going to open it up to everybody. Sarah, thank you very much. We really appreciated your time and passion and your expertise. Thank you. So we will pass it on to go ahead, and then we'll.
I think my question may have been for Sarah. It's with regards to audits. So get an energy audit done to assess all the heat loss, and I know I've got lots of it. What do they require that you do things in a specific order? My example being, I know that my windows are not very efficient windows, but they're there. And I think that my furnace, I'd like to replace, I think there's a need to replace the furnace with a heat pump before I put out the expense of replacing all the windows. Does it matter how I do that with regards to rebates as far as the order things get done?
Who would like to take that on?
Goldfish.
Oh, did you want to?
Do you want me to just answer questions?
Thank you, that would be much.
Sure.
Go ahead, Audrey. Let's go to the mic. Can I use the mic?
Or either.
Okay, the order that you do your retrofits in is totally up to the homeowner based on economics, and which are more expensive and less expensive. For instance, spot air sealing can be done by a homeowner with a caulking gun or a foam, you know, where they're really working hard on their own and it's not very expensive. Whereas something like an out-of-flat main wall, which is really creating an airtight air barrier on the outside and add insulation, can be up to $50,000 depending on your home. So, you know, you're going to have to work out the economics versus the strategy. But what Goldfish does is something called the Clean Tech Roadmap. And what the Clean Tech Roadmap does is it lays out for you the order of things where the primary things that you do benefit you on the other steps. So for instance, it will say to you, first of all, you attack the passive improvements in your home, which would be things like reducing air leakage and increasing insulation. Those are a one-time cost that benefit you down the road and reduce the size of your mechanical equipment in the whole run so that you're actually spending less on the size of your heating and cooling equipment. So you would always do your outer envelope, your attic, you create an environment that can be climate controlled within the house. Then you add your mechanicals, then you understand the cost of electricity for those new mechanicals, and then you add solar panels, which will give you electrical generation to match your needs, and once you match your needs with your generation, you are net zero. Those are the phases, that's the steps you would take. But again, that has to be a balance between economics and homeowners' ability to work through those steps. We give you a roadmap that you can hang on to and do this over 10 years. So that you have some guidance.
Great, thank you. Thank you, Anna. That's great. Do we have a question from the chat?
Hey, John wrote, I find with the central heating cooling system, there are several degrees differential in temperature between the floors, even with strategic closing vents. Can this differential be reduced with heat pump systems?
I think that's very Bob.
Okay, so I've already said I've been in the industry 55 years, so that makes me qualified to not hear everything that's said on the question. So could you repeat that again, please? Or give me the Coles notes?
Yeah, okay, so I just put it on the video.
Oh, good.
Okay, so upstairs is warmer than downstairs.
Oh, okay, all right.
So heat pumps fix that.
Thank you for asking that question. It's a good one. There are a number of things that can make that better. Heat pumps are part of the answer. The reason you're getting differential temperatures between upstairs and downstairs can have more than one problem occurring at the same time. Quite often it's air distribution. Second floors of most homes are not ducted correctly right when they're built. Therefore, they have a deficiency in airflow to the second floor. Also, getting back to the building envelope, if you have a second floor with an attic that isn't well insulated, or again, you have a leaky house, because if you think about how a house is built, we have what is called a stack effect. Air comes in the bottom of the house in the basement, rises up through and leaves the attic. And as a result of that, you can get temperature differentials from basement to second floor as much as 10 degrees. And in the summer, even worse, because the basements can stay cold and the upfloor can be very warm with the heat load. So there's a multiple things that can happen that can correct it. Airflow can be improved by having furnaces and or air handlers that have the newer ECM variable speed fan motors in them. That'll help a little, but ducting is usually, or air distribution is usually an issue. Each house is quite different from one another and needs to be investigated to see what's exactly happening. Static pressure tests are the first thing that are done.
Thank you. Hi, Kathy?
Thank you. Yes. Thank you. This is a wonderful program. Thank you for the organizers and participants. I'd be interested in asking both of you as well, I guess as Audrey, who works with Sarah. I understand the incentive for sure with the natural gas and of course the green reasons, but we've got a 1950s bungalow that changed to electric baseboard heating with 200 amp service in the 70s. So we kept the ducts and the air conditioner still works. Does this apply to us, this changeover and the grants and the value and the benefits and so on?
Thanks for that question, Kathy. It's an important one. What we're finding is that a lot of the conversations are around central heating and cooling systems where you have a furnace with ductwork. In Europe and as with Kathy, there are people who prefer radiators and boilers and zone heating where they have baseboards in each room. So there's an advantage to zone heating in the respect that some areas you live in more and you want to keep warmer, and some areas you sleep in and you want to stay cooler. So there's a good advantage to zone heating. The difficulty is that we now have to replace the boiler, which works very well with high BTU gas burning, with a boiler system that is produced through heat pump technology. So in Europe, they're achieving good things around that. And you can obviously, these days, you can get a water heater heat pump system, which means that it's a heat pump heating your domestic hot water. That is possible. The higher temperatures of the radiators using a gas boiler are what people are used to, but it is possible to do radiators with a heat pump boiler system. You just have to understand that the temperature level is not quite so high. And it still makes for a very comfortable home. And so we encourage people to ask about switching, even if they don't have central ductwork. There is also the option of what we call mini splits, which is ductless heat pump systems. And in that case, they are a head on the wall. You might have seen them in people's homes. And so they work best in a situation where the air can circulate through the home. And so an open concept area is the best situation when you are ductless and using a mini split. You can combine your mini splits with radiators. You have to be a bit creative. You have to be a creative thinker in your home where you have options like those. And that's where someone like Bob is going to give you good advice on how much air distribution of warm and cool air you'll get when you do a mini split, and how you want to approach it. Does that help?
It does help. We actually have electric baseboard heaters, full ductwork from the old days that is used for the air conditioner that's worked for 30 years and is still going. So hopefully the grants would apply. I'm not sure.
Oh, yes, the grants.
I think there was a slide on electric heat. One of the TCRA slides had like 4 programs. I think at the end it said for all electric, because when you go to the heat pump, you use 1/3 less energy for the same heat. So that's still in the interest of the GHG reduction.
The grant applies to heat pumps, whether they're mini splits or centrally ducted.
Okay, thank you.
From Bob or from Miles.
Sorry, I think we have to move on with other questions. Is there a question in the chat?
Miles, what are the key targets that Richmond Hill homeowners will be expected to do to achieve net zero?
Okay, thanks for the question. So I'll mention again that the overall goal of net zero by 2050 is for the community. For specific homeowners, I mean, we have targets like that. I mean, we're looking for all existing homes to switch to heat pumps, for example. So that's our target. It involves the community, but it's not necessarily specific to how much an individual homeowner needs to reduce their emissions. It's really more about these broad steps that are going to, on a community level, help us to achieve that target. So I'm not sure if that's kind of answering the question, but within our SEEP, there are more specific targets around homes and buildings and some of the changes that need to happen, but they're not really parsed down right to an individual home, and this is what a homeowner needs to do to play their part. It's like I think it's all these changes that we're talking about kind of collectively helping us to get to that target. So I'm not sure if that totally answers the question, but I think it's safest to say that any steps that homeowners can take are important and are going to help. And the SEEP really kind of contains the community-wide targets.
Thank you, Miles. I'm just going to mention time. So we have 8 more minutes. So hopefully we'll get some more questions in, but if you do have a question, get it in. So Andy?
Yep.
There's been a lot of talk about home energy audits, and we actually did a home energy audit ourselves a couple of years ago now. So I was just thinking it might be useful to give my experience rather than ask a question. So we had the auditor come in, and they made quite big recommendations. You know, replace these windows, loft insulation, all kinds of things that you could do. But there's a whole list of things, from very small things to bigger things. So it's really kind of up to you how much money you're prepared to invest into that. And we actually did, we did insulation in the loft, so we've got something like 3 meters, huge amount of insulation up there now. But the other things were just very, very small things. I removed all the vents in the rooms and put the silver tape to really seal the vents well. I took off the quarter round in various places on the floor, put in sealant, replaced the quarter round around the doors. Simple little things. And when the auditor came back, I can't remember quite what the numbers were, but the numbers have gone from like a 3.5 to a 4.5 or to a 5 or something. And he said it was actually one of the biggest differences he'd ever seen in the audits he did. And we really, other than the insulation, most of the things we did were quite minor. So I'd highly recommend to sort of getting audits, even if you're not thinking heat pumps yet. Get the audit done, and you can make a significant difference to your home's, energy consumption just by those little things.
Thanks, Andy. Really good tips. Question from the chat?
Yeah, Marta, regarding water heaters, did you investigate the difference between heating with electricity versus a heat pump?
Yes, I did, and it came down to cost. I felt at least I was getting away from my gas water heater and going to an electric, but the heat pump was going to be significantly more that I decided just to go with the electric water heater.
And
I do have like a lot of people construction community, their house age is maybe 50 or 100 years. But I would love to achieve the best result of my community. The house is around 10 to 15 years old. And my furnace is around 12 years old. And the aircon was like replaced with a new compressor at 4 years old. I just wonder if the mom are the benefit would be outweighed for replacing things that is not old enough, that be not being very environmental. So I kind of like community people was struggling with what should I do if it's not old enough to follow? They have a lot of energy. So any advice?
It really depends on how environmentally conscious you are. 12 years is like borderline. Anything like I recommend for people to go the hybrid solution if their furnace is like only 6 years old. But by 12 years old, you're starting to get to it may die soon. And if you feel environmentally conscious, then I would replace the whole system with a heat pump. As I say, if it's younger than that, then hybrid is okay. And as you heard Eric say, even though he went with a hybrid system, he's never had to use the gas, because his heat pump does all the heating and cooling for him. So I still think it's worth investigating.
And have the aircon component that is not that old also as well.
What do you mean, the air?
conditioner?
How old is the air conditioner?
It was 5 years old, but it was done and we replaced with a new compressor. 4 years.
Okay. Bob wants to answer that question.
So you mentioned it's how old total?
It was 12.
Okay, so, okay. It concerns me that a new compressor was installed to start with. I mentioned in the information I presented was contractors didn't use all of the principles they should have been using in air conditioning. And quite often compressors failed because contamination, moisture, even though they work in warmer climates, there's something going on that caused that compressor to fail. And typically when that happens is you have contamination in the system now again, because the failure caused contamination, and now you have a new compressor, it's going to fail too. So with a failed compressor out of warranty, typically we would change the equipment for sure. The other, on the gas side, I've seen 12-year-old furnaces that look like they're maybe 3 years old because they've been maintained every year by a competent service technician. I've seen furnaces that are 10 years old that look like they're 30 years old for the same reason. They haven't been maintained. So the age of the equipment isn't just the indicator. It's what, first of all, is it oversized? Is it the right equipment to start with? Secondly, is it performing the way it should? All of those are reasons, no matter what age it is, to investigate whether that can be repaired or replaced. So all of these are factors. Age of the equipment isn't necessarily a standalone.
So we're just 2 minutes out. So there's a quick question, and I know there's a gentleman here.
Yeah, I don't have so much as a question. Hi, I'm Jason. I'm also an HVAC contractor. I just have two important, very important comments, which haven't been mentioned. If anybody is interested in a heat pump, whether it's from any contractors you may know that have been serving your equipment or anybody who's met here today, very important. This was supposed to be a 4-year plan program, but it is ending very abruptly by the end of February, early March. Please know that you may all be excited and maybe planning to do this in the future or maybe next year. You can. There'll still be some maybe smaller one, but it will be the majority of this big budget that came out is done. It went very fast. So if you want to do full rebate, which is $7,100, that'll end within 3 months. So if you want 90% of homes to get basically a heat pump system for the rebate, so it won't cost you anything at the time. $7,100 check will cover the whole thing, taxes, audit, everything. A to Z, so zero will come out. You would want to take advantage of that as soon as possible, if that's what your plan is. Enbridge customers will get the full $7,100. If you're not an Enbridge customer, you get $5,600. Thank you. If you need a card, I'll leave some over there.
Great, thank you. And one last question from the chat. I'll try to quickly fit that in.
Perfect timing.
So when you switch to the microphones, it moves the mouse on the screen, which we see the chat, which is why it's taking so long. Okay, what suppliers provide these CCAA-HP currently? There's the question on the board. So if you...
Air source heat pump.
Yes.
Whether they manufacture them themselves or are importing them, have a line of cold climate heat pumps. In most cases, multiple lines. So they're available from all suppliers. And of course, contractors buy from suppliers. Suppliers will not sell you the heat pump directly. They're also through contractors or distributors. All of them.
What's an example?
Okay, what we will, we're going to be sending a thank you email, and we will be able to slide it up.
I think the two questions, like, what are the big brands right? Like,
Your slave carrier is BCO, is that a building show where they're showing the heat pump?
Yes.
It's all, but they have to be pulled by it,
Yes.
they have to be approved by HRA, they have to be on the list. And as I spoke to the fellow member at the lab, the program may go for March, like that, everyone said.
Okay, so we will provide you with a list in our agreement. So we're just wrapping up. Oh, sorry, we really have to end this.
Mr. What you send out, you also please send the contact information for.
Sure. Everybody's contact info, all the analysts, sure, and Eric as well, sure, we will do that. And also our website, which you will get a link again in the last email, will also provide all that information on the website. So please join me in a round of applause for our wonderful panelists. We are really thankful for your time and expertise in coming here today. Also, we want to thank the volunteers who helped make this a success. And so this wraps up our time, and note that there's no time to visit the municipality table. Student guests, you're going to have a link in the chat where you can also get these materials online. Marta has mentioned that she provided bringing the documents that she did talk about in her talk. We will also be providing Miles's email and Esther as well, so that if you're not sure who the question to go to, Esther will get it to the right person. We will be sending out a short survey. We really hope that you'll take the time to fill it out to help us, to guide us in our future endeavors. Please visit Neighbors for the Planet website where we have all our information. We have a heat pump page, and also the Richmond Hills climate change page. We also have Climate Action Newmarket. Aurora has also brought some lawn signs, so if anybody would like one, please leave a friend. And finally, we do have a donation box at the registration table, and if you're able to, please kindly donate a few dollars to help cover our costs for this event. Thank you so much for attending, and we hope to see you at future events.